As we continue through the general outcome, develop trigonometric reasoning, we move on to part 5. It is expected that students will solve algebraically and graphically first and second degree trigonometric equations with the domain expressed in degrees and radians. So that's certainly a whole lot of words. What does it mean? Well, what it means is that you could have problems like cosine of theta minus 1 equals 2. And you're expected to solve these. You can go through this algebraically and say, okay, cos theta equals 3. So theta is the inverse cosine of 3, which leads us to the conclusion that there is no solution amongst the set of real numbers, because the range of cosine is only between plus and minus 1. So you cannot have the cos 3. You could, though, have 2 cosine theta minus 1 equals 0, which gives us 2 cosine theta equals 1. Cos theta equals 1/2. And now theta is the inverse cos of 1/2. Now, if you were to run that through your trusty calculator, while you're in degree mode, it's going to tell you theta is 60 degrees. It's going to give you one answer, and it's going to say, yep, that's it. But that's not the case. If we recall, these functions are periodic. So the solutions that we have at 60 degrees are only one of infinitely many solutions if we look at the whole real axis. In fact, we have another solution at 300 degrees. Don't believe me? Grab your calculator again. Take the cosine of 300 and see what comes out. Take the cosine of 420 degrees, or the cosine of 660 degrees, or the cosine of negative 300 degrees, or negative 60 degrees. All of these are going to end up giving you 1/2. So these algebraic equations to first and second order are going to be producing a number of solutions. Now, in some of our equations or some of our problems, they're going to tell you we're restricting it to a particular domain. And that is going to tell you that it's going to be just these two in this case. They could tell you they're restricting it to just one quadrant, because each quadrant will have a maximum of one solution. So you could have quadrant 4, or quadrant 1, or quadrant 2, or 3, or some pair of them, but you may end up with just having one solution because of restrictions on the domain. You may end up having infinitely many because of restrictions on the domain. And that's a first order. What does a second order look like? Well, there you could have things like cosine squared theta minus 3 cos theta. Actually, we'll go 2 cosine squared theta minus 3 cosine theta plus 1 equals 0. So something like this is second order because it's like a polynomial of degree 2, except instead of having x, we've got cosine. But we can still solve it like it's a polynomial of degree 2. This, if we apply our quadratic equation formula, gives us 3 plus or minus the square root of negative 3 squared minus 4ac all over 2a, or 3 plus or minus 1 over 4, which gives us solutions of 1 and 1/2. But remember, these are solutions for x, and we put x where the cosine of theta is. So we will actually have two sets of solutions. We'll have the set where the cosine of theta equals 1, and we'll have the set where the cosine of theta equals 1/2. So for the first one, cosine of theta equals 1 at multiples of 0, or at 0 and multiples of 2 pi thereafter, or 360 degrees. So here theta is going to be 360 degrees times n, where n is an integer, which we do have to specify. Alberta curriculum likes to use I. Everything after graduation will use Z. Cosine of 1/2 in our first period from 0 to 360. We've got those solutions at 60 and 300. So then we're going to have added on to those multiples of 360. Now note that because n is an integer, we don't need to have the plus or minus here. We can just say plus because we could just put a negative value of n, and that will take care of it. But this is what it means to solve first and second order equations. You solve it as though your trig function in and of itself is just a variable. And then you have to ask yourself, how many solutions are we going to have in the specified domain? And you'd have to write an expression that represents it. So these are the basics of the trigonometry.